Hi, this is Paul and I've got another new video to show you, and the name is QUAD STEP PHYLLOTAXIS 3D Order Lesson 6. In my last video, Lesson 5, I showed that the three polyhedra, the ICOSAHEDRON, dodeca and icosa, when using the vertices of the icosi, as shown, you could get fourfold geometry, no problem. You can see in front that the orbital rings are in the X, Y, Z polar arrangement, and this lines up with the octahedron perfect. And you can see that these spherical profile rings in the XYZ position line up perfectly to the cube, the dodeca, and the icosa and the tetrahedron in a wonderful geometry. And you can also see 32 balls of 4 different colors all lining up to the geometry in perfection. Okay, now we're going to focus on the fivefold geometry of these three polyhedra. Now notice that the center vertical axis is going through the top faces of the icosahedodeca. So now I'm going to spread them apart again so we can see the three polyhedra separately. And now you can see that the center axis is going between the vertices of the icosa this time. So the icosa is the boss for fivefold geometry. Okay, the next job is to give it a spherical ring, a profile ring on the three polyhedra. Now these three rings are different. The icosi and dodeca are root 3 times 6 and the icosa ring is root 3 times 5. Okay, the next job is to give the profile rings a 40 copy polar array. Okay, my next job is to show latitude rings made up of colored balls for QUAD STEP PHYLLOTAXIS. Now this is an incredible find because these latitude rings of 40 balls all line up to the vertices of the three polyhedra, no problem. Okay, so now I'm going to bring the three polyhedra together again for you to take a look at. This 40 ball PHYLLOTAXIS system is something special because let's take a look at the geometry of the pineapple. In front I show a stack of 18 rings with 40 balls. Now this stack of 18 by 40 converted to the geometry of a pineapple as I show. Now I made a copy of 40 longitude edges, but it's actually half that. There'll be 20 closed edges, just like closed rings. Okay, I'll give it a spin around and you can see the geometry of the pineapple. And it's plain to see that QUAD STEP PHYLLOTAXIS with 4 different color balls does the job and there's no arguing about it. Okay, we'll go back to the geometry of the three polyhedra again. So now I'm going to change this to the top view for you to take a look at it. And if you study these rings on the geometry of the polyhedra, you can see that they line up perfectly. This is a major discovery. It beats me why so very few people are interested. I'll bring the three polyhedra back to the center again for you to take a look at it, because I really think this works just the same as a three-dimensional processor. Now I'm going to show you the front view of a polar array of just 5 rings. So now I'm going to give it a spin around. And you can see the perfect symmetry of this QUAD STEP PHYLLOTAXIS. Now I show just 5 rings, but these rings actually are 10 segments, and they'll double up again to 20 and then again to 40. Now the circle is made up of 4 quadrants, so the 4 colored balls work out perfect. Anyways, there must be a couple of scholars around the world that think this discovery could do something. So this is Paul saying thank you very much to the very few people that like my video.